So my name is Neil Dennis. I'm a senior applications developer for UMB. UMB is a financial organization. I also run a consulting company as well. I'm representing UMB since they paid my trip here. So they did that. We're going to talk about a little bit about the PDF and how we can kind of build PDFs in 4D code. First thing I thought I'd do is I'd show you the inside of a PDF. I think if I hit that there, here we go. So if you're looking at this document here, looks like we have something at the top here. It says PDF, so that way we know it's a PDF. All your PDFs will begin with a little percent and then a PDF. And then it has some other stuff there. And that makes up the PDF document. And if we were to double click it and look at it, let me do that here real quick. Drag it over here. Is it launching on your screen? No, there it is on mine. And there it is. Okay, so that's about my presentation. Any questions? I'm just kidding. All right. Basically, if you aren't familiar with PostScript, this kind of all looks foreign to you. This is actually, a PDF document is written in the language of PostScript. It was not a full-blown version, but it's a smaller version of PostScript. So if you recognize all this, this is PostScript's code. Now, it's really hard to learn a language in 50 minutes, but I'm going to do my best to show you enough about it that this won't look so foreign to you. You can kind of read it and figure out where to go from here. So let's go back to the slides here. Let me find my mouse again. So the first thing you have to understand about PostScript is it's a stack-based language. That's different from 4D, which is not a stack-based language. In a stack-based language, let's see, I already said it was done on PostScript. In a stack-based language, you use reverse Polish or sometimes postfix notation. What postfix notation is you put your parameters first, and then you execute the command on those parameters. Well, some of you have calculators, old calculators, where you'd like put in a variable, and you'd say enter, and put in the next variable, and say enter, and then you do plus. And they would add those two, pop those two off, and add them together. It's kind of the same with the PDF and PostScript, is that you'll put your parameters first and afterwards. So it pushes the arguments on the stack. So if you push like a 7, it goes on the stack. You push a 5, it goes on the stack. Then you push something else. Well, we'll go into a little bit more. So say you have a 4D method, and it's called sum the two, or sum them. It's going to take two numbers, it's going to add them together. In a 4D traditional format, you'd pass in the command, or do the command, sum them, that's calling the method, and then you pass the parameters after the fact. Parameter 1 is a 2, and parameter 2 is 3. Now that I say that, this looks kind of confusing. I should have made them 1 and 2. Anyway, but you get what I'm saying. To do this in PostScript, what you do is you'd put the 2 first, then the 3, and then you call the command. Okay? Now, you might say, well, okay, but where's all the semicolon between the parameters and the parentheses and stuff around it and stuff like that? In PostScript and in PDF, you have white space. And your white space will separate anything. You can use carriage returns, you can use line feeds, you can use tabs, you can use spaces. Anything separates them. So you don't need semicolons, you don't need parentheses. You just put your first parameter, then some sort of white space, then your second parameter, some sort of white space. If you have 3 parameters, another parameter, as many parameters as you want, and then you do the command to execute them. So that's kind of how this code works. So let's do some more examples just to kind of pound this in. So like here's a command that sends you in the 4D screen 10 over, 20 down. And so you're about to write something. You can use it in message commands. It's kind of an obsolete command, but it's fairly simple, and it has a direct PostScript equivalent, so I use this one. Does anybody ever use the goto? Okay, a couple of old timers here. You young ones probably won't. Okay. So the same code written in PostScript is 10, 20, and TD. And the TD command is the one that actually moves the cursor around to a certain place before you're going to draw. So if you do like a message hello world, again, the 4D way, you have the method name and then the parameter on the right surrounded by parentheses. In the PostScript way, you have hello world and then the command to draw it. Now you notice that hello world has parentheses. We'll get into that in just a minute. First of all, let's talk about comments. Every language you can make comments in, and in PDF language, or PostScript language, we're just going to call it PDF language for now, because really it's not real PostScript. In PDF language, they have comments as well. So, A comment is done by a percent sign, and anything after the percent sign till the next line feed or carriage return or whatever is considered part of the comment. It's very similar to the single quote that 40 uses or the double slash that 40 uses. Everything there is a comment afterwards. So if you take these two lines, you have ABC and then a percent, and then you have some comment, some other stuff, blah, 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 and then you have a 1, 2, 3. That line in PDF is exactly the same line as that right there. Okay, so it takes everything from the parenthesis, clear to the end of the line, and then you just have some white space. Now in this case, I used a return for a white space. You can use a space for a white space. So those two are equivalent in PDF formats. Any questions on comments?
Why are you escaping the percent sign? Or is that just...
That's just garbage I threw in there. There's no escaping characters. All this is a comment. You can put anything there. It is all ignored. You can put, whatever kind of characters you want in there. They don't even need to make sense characters. So you can put anything there. Okay, let's talk a little bit about objects, PDF objects. An object isn't what you think as an object, like a C++ object that contains methods and things like that. An object in PDF is more of you might consider it a variable type. For example, a Boolean is an object, and it has the value of true and false. You have the integer, and for you French people, it's integer. You have a minus or a plus or something like that, and just a whole number. Real numbers are what you'd think of real numbers, exactly the same. Strings, here's where you get this parenthesis that I was going to tell you I'd talk about later. A string is characters, but it has surrounding parentheses. We'll talk a little bit more about string because they have some kind of interesting nuances themselves. In fact, we'll talk about strings now. So strings can contain white space, new lines, as long as you have parentheses, because a string is a number of characters. A starting parenthesis, any amount of characters, and then a closing parenthesis. You can have anything in between. As long as you have balanced parentheses inside the string, you're okay. If you need to do like just one parenthesis, you're going to have to escape it with a slash. I'm not going to go into all the different types of white space and special characters. If you open up my documentation that comes along with your USB drive, I go through and explain a lot more about strings and special characters. The one I do want to point out, we have new lines, returns, tabs, things like that. The slash and then the 3 little pound signs. I don't know how many of you are hardcore programmers. Have you guys ever worked in octal or hex? How many do not know what I'm talking about when I say octal? Okay, there's a couple. Okay, so you're not going to get this joke. Okay, why do programmers get Halloween and Christmas confused? Because octal 31 equals decimal 25. Okay, so for you that are not familiar with octal, octal is a way of writing code that's a little bit different, numbers that's a little bit different. You can write numbers in base 10 like we do. You have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it starts over with 1, 0. You can do numbers in binary, where you have a 1 and a 0. You go 0, and then, oh, wow, we're out, 0, 1, and then you're out of numbers, so you have to go to a 1, 0, and then a 1, 1, and then a 1, 0, 0, and then a 1, 0. You get the idea. In hex, you have 16 digits, and you go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, we need some more, so we'll put in like A, B, C, D, E, F, and then we'll start with our 1, 0. In octal, you have 8 characters, so you go 1, 2, 3, 4, 5, or 0, 1, 2, 3, 4, 5, 6, 7. There is no 8, and then you start over with 1, 0. But a lot of that you don't need to do because calculators are so cool now. So let's go to a little quick demonstration on how to switch if you ever need to get an octal number in your calculator. So here I have a calculator. It's just the basic Apple calculator. Windows has pretty much exactly the same thing. If you go to I think it's a view, you can pick the different type of calculators that you want. Scientific gives you cool things like, pi and radians and degrees, stuff like that. But the coolest one is the programmer calculator. If you look at the programmer calculator, it has these numbers right here. Base 8, this is your number base. This is octal. This is decimal. And this is hexadecimal. Okay? So if I want to type a number in decimal and say I make this number 25 and I want to find out what it is in octal, I just hit the 8. You can see it's 31 in octal. Okay, so you can do quick number conversions this way. If I want to see what the number 25 is in hex, I can do that, and it shows me that it's 1, 9. And if I want to see it in binary, this is the binary representation of the number there. The Windows has a very similar calculator, so if you need to switch numbers around, use the calculator, and you don't need to do all the math in your head. Okay, you know, the type thing says there's 1, 0 type of people, those that understand binary and those that don't. Remember that joke too? Okay, that's where that comes from. I'll scratch that one from my list of jokes. So that wasn't that great. So basically, that's what, let's go back here. So these special characters are in octal. So if you need to put a character, put them in octal, put a slash, a character, and that'll give you all your special character codes. It'll get you like European pound signs and things like that that you may need to put in your PDF. Okay? So let's go on and look at hexadecimal strings. Again, this is a little bit geeky, and you may never need to use it, but if you need to, you can. This is a string written in hexadecimal. What a hexadecimal string, instead of starting off with a parenthesis, starts off with a greater than and ends with a less than. You don't need to worry about special characters because it's all hexadecimal. Hexadecimals are 2-digit numbers in PDFs, so they'll always have 2-digit numbers. So if you count these, you got 1, 2, 3, it's an even number. Okay, you got about 14 there or something like that. Now, had it been an odd number, the PDF will automatically assign a 0 at the end. So if you look at these two, 901FA, that's 1, 2, 3, 5, it'll automatically be a 0, so those two numbers are the same. So it'll automatically round them out for you. You probably may or may not ever need to know hexadecimal, but it's there, so well, that's why we discussed it. I turn my mic off, I got a cough. Okay, everybody plug their ears. Okay. A name is a special type in PDF, and a lot of things need to be named. You'll name fonts, you'll name other things like that. A name starts with a slash, and a name cannot have any white space in it. That'll be a termination of a name. So this one is a good example. You have a slash name, and then it looks like an I, but it's probably a 1. But it could be an I, or it could be a 1. But that's a valid name in a PDF document. Another name is, this one is valid as well. You can have all kinds of weird characters in your names as well. And this kind of defines, like I say, a name. If you need to put a space in a character, you can use the little pound sign and then the hexadecimal value of it. In case you don't know, 20 is the ASCII value 32, which is a space in ASCII code. So those two strings are the same. PDF also has arrays. Arrays first of all, they're one-dimensional. You don't have any more dimensions. You can't do a 2-dimensional array in PDF. They're heterogeneous, which means that you can mix data types. You can have a string, you can have a name, you can have a number, and any order that you want. They start with an open square bracket. Then you put all your information separated by white space, and then a closed bracket. So if you look here, we have, it looks like an integer, then a real, then a boolean, then a string, and then a name. And that's all elements of the array. Another type that we want to talk about real quick are dictionaries. Dictionaries will start with a double arrow, and then it's like a name-value pair. It's very similar to a 4D object in that it's just a name and a value. So if you look here, the first one says type, that's a name. Example, that's also a name. But that's a name-value pair. The value is a name called example. The next one says subtype and dictionary example. That's another name and a name. The next one is a name and a number, a real number. Then you have a name and an integer, a name and a string, and a name, which is a subdictionary, and it's an object that's another dictionary in itself. Dictionaries are just name-value pairs, and you can have subdictionaries in there. We'll use those on occasion as well. Objects, true objects. Let's talk about true objects before we get to indirect objects. Okay, an object is a collection of data types. Similar to a dictionary, but an object, you don't have to have a name value. You can just group them together. Objects start with a keyword, obj, and end with the term end obj. But first, objects also have a number, so they can be found in the PDF, and then they have a revision number that follows. Usually, the revision number starts off at 0 and is incremented anytime you change the object. The object number must be unique in a PDF document. I like to start my numbers at 1 and just kind of go up. So if we look at it, the first number is the object number, the second is the generation number, the revision number, and they're encapsulated by OBJ and end OBJ. So there's the start of 1. It's object 32, it's revision 0, and the start, you know it's an object because it says OBJ afterwards. I'm going to put some text in there. The text is surrounded by parentheses, so we know that that's static text. And we do an end OBJ. So this is an object that has text in it. That's the only thing that we have in it. You can put anything you want in an object, though. Okay, now let's talk about indirect objects, because indirect objects are kind of what are used to give PDFs a smaller size, and you can reuse objects. So if you put an image in a PDF, you only need to put it in there once, and you can reference it anywhere. To reference an object, you need the object number, and then the revision number of it, and then an R. So that right there is referencing object 32. So remember the other object that had text in it? We said it was 32.0 OBJ, and then it had 32, and then it ended in OBJ, or OBJ end. This is a reference to that. It's like a pointer to that object. So whenever you put that there, it's going to look it up and substitute in that code everywhere else that object was used. So that's a way to reference an object. So, I mean, text would be kind of stupid. It's only 4 or 5 characters anyway. But if you have like a huge picture, like 10 or 20K, and you only want to store that once, but you want to use it on every page of your document, you can put it in once and then just put the reference on every page, and you only store it once in your document. The last thing that we want to talk about, and I think then we go to another demo, and I'll kind of show you how this all comes together, are text blocks. Text blocks not only define the text itself, but also tells you where the text will be and what font and size and things like that. So let's look at a text block. They're kind of special objects, and we'll use them a lot. So a text block is surrounded by BT and ET. BT, I assume, stands for begin text, and ET is probably extra text, end text. So you start with a BT. Now, if you notice here, we have a /F13. You should recognize that as a name. Anything with a name is /. So the name is F13. Well, in a directory someplace in my document, I've defined what that name means in a subdirectory. And so that's a font name. And I just gave it the name of F13. Then you see a 12 and a TF. Okay, the 12 is the font size, and then the TF is a method. So right here, I'm pushing a font name on the stack, I'm pushing a size on the stack, I'm using the TF command to pop those two off. So that tells me the font size I want to use is font that is named 13, or F13, and I want to use size 12 of that font. The next line I'm putting in are two numbers, 288 and 720. Those are XY coordinates of where I want this text to show up. The TD moves the draw tool to that point. So now it knows the font, and it knows where it's going to draw it. The next thing I put in is the text. Remember, text has parentheses around it. So that's a text parameter. And then the TJ is what renders it on the PDF. And then my end text block. So this text block tells you what the font is, what size it is, where to draw the object, and then the command to draw it itself. And we put that all in a text block. We'll see that pattern a lot in a PDF. Okay, I should talk a little bit about XY coordinates, because PDFs did it mathematically logically, but programmatically kind of inverse. When you think of a coordinate system, you think of something like this. Your X direction goes this way. I should do it larger. X direction this way, Y direction this way. You learned that in math, right? So if you get in your X coordinates are first, and then your Y coordinates. So you go over 1 and up 2, and you're somewhere like right there, right? Well, that works great if you're doing math. But if you have a piece of paper, and this is the bottom left of the paper, then the top is way up there, and the bottom is 0. Well, when you're printing a paper, you usually start from the top and work down. So like if you use like a print form from 4D or something like that, or most of your printing objects, your scale is reversed. It's more like that. Okay, so your corner is your 0, 0. Positive x is this way, and positive y is that way. Okay? PDF does it the mathematical way. So it's like this. So this tells you here that this is your x-coordinate. So you're going over 288 points from the bottom corner of your screen and then up 720. Okay? So knowing that you guys are more 4D programmers and think 4D, I wrote a little API and some wrapper tools to make PDFs, and we'll get into that later in the session. But I flipped the axis on you so that the upper left and so the axis as it goes positive will go down, and I made it more how we think. If you don't like it, you can always flip it around. Yes, question? These are methods inside the PDF. TF says that this is a font, and it defines the font. A TD is like a move command and moves. And a TJ command is actually to draw stuff out. So if you ever did something like turtle graphics, I did that when I was like tell you move and then line to and then draw and things like that. It's kind of what this is. Okay, a couple more data types, and we'll get through the boring stuff and we'll get into some real stuff here. A stream. You need streams to do all kinds of data, like for pictures and things like that really have no structure. So streams start with a dictionary. Remember, a dictionary is a double surrounded by double greater thans and double less thans, and their name value pairs. Okay, so it starts with a dictionary, then it has a keyword stream, it has 0 or more bytes in this stream, and then the word end stream. Okay, why would you want to use a stream? Oh, sorry, and it also has to have a length in the dictionary. So the dictionary, one of the keywords has to have the name length and the number of bytes in the stream so that it knows what it is. Streams, like I say, can be used for pictures or applications. You can actually embed an application in a PDF if you really wanted to. Like, here's your Word application and give it to somebody in a PDF. I don't think you'd ever really want to do that, but you could if you wanted to. So streams are just kind of binary data that really have no other representation. So let's look at a stream here. We're going to put the stream inside of an object. So this is object number 7, revision 0. And it's an OBJ, so we know this is the beginning of an object. We have a dictionary here. You can tell it's a dictionary because it has the double greater than and the double less than. It has a name-value pair. The name is the length. The value is 80R. We know that 80R is a reference object. It's referencing another object someplace. Now you notice that 1 is a 7, and it's referencing 8, but 8 hasn't been created yet. This is really cool, because if you want to put out a stream into a PDF, you need to have the length up here. You're going to be writing out the stream, but you may not know how much you're going to write until you're done. Well, at that point, then you can put in the real object 8 with the correct length, and it will know where it is. So you can write your length afterwards, even though you have to put a placeholder up here. So the references don't have to be defined. You don't have to know what a reference is to know, what's the word? It doesn't have to be defined before you use it, I guess. It can be later on in the PDF. So then it has a keyword stream. I'm going to make this one a BT, so it's going to, I'm going to put a text block in here. It's begin text. There's the font definition. I'm using the font named F1. Its size is 12, and I'm going to call it TF to tell it where to go, or to tell it which font I'm going to use. The 72, 712 moves me over 72, up 712, and puts me there so I can draw my text. I didn't give it any text to draw, but just kind of moved it there. And then I did my end stream. So in a sense, this stream does nothing. It sets the font, moves the cursor, doesn't draw anything. Okay, but it's okay because we're just demonstrating a stream. We end our object. So this object here is a stream. Remember I told you we needed the length in there as well. So we create object 8. So it has object 8, reference 0. It's the beginning of an object. We put a 31 in there. That's the length. And we end our object. So that's the same as putting this 31 clear up there by our reference. Okay, yes, question? Indirect, yeah, you could probably use an indirect object there as well, if you wanted to. Okay, so now let's go back and look at our sample PDF again. And if you remember how foreign it looked, let's see if we can pick out the parts of it. Where did it go? Oh, it is there. Okay, I'm just on the wrong screen. So if we look at the top, we see that it starts with a parenthesis. Now, who remembers what the percent? What does the percent mean? It's a comment. Every PDF starts with a comment. So you can ignore this line. It does have some meaning to the PDF, and we'll get into that when we talk about the PDF document structure. But you can tell that this is a comment. This next line, also a comment. Okay? We'll talk about the meaning of this comment in just a little while. We know that this right here is the start of an object. It's object 1. Its revision is 0. Here's the object, and it has an end object. This object, we see, has a dictionary. And dictionaries are name value pairs. It has the name type, the value catalog, the name pages, and a reference object right there. So this basically says that, there's a catalog and its pages are someplace else. So let's go down a little bit more. We see another object. This is object 2. And we see it has a dictionary with some name value pairs, media box. That one happens to tell you the media box is the size of your PDF. So if you want a 10 by 10 page, you put in 0, 0, 10, 10. If you want 1,000 by 1,000, you do 0, 0, 1,000, 1,000. So that just kind of defines the size of your page. We have some more here. Here's another object. It also has a dictionary with a sub-dictionary, and even yet a fourth sub-dictionary. And this is kind of some fonts. If you remember, I've referenced font 1. There's the name, and there's the value. And so this defines a font. And then later on, I just use the font name. Okay? I show you this stuff so you can read it, but unless you really want to dive into it and hand code this, typing it yourself, you won't need to know it. And I do explain this a lot in my notes, so if you really want, if you really want to do that, I will let you do that. But there's better ways to do this. So let me zoom out here a little bit. Keep going. Okay, here we have object 4, and it's a stream. We put in the length. We knew the length up front, so we just put it in there. Begins with stream, ends stream. It has a text block that sets the font, sets the location, does hello world, has end stream and end object. And then the thing that we haven't discussed yet, when we get into the documents a little bit more, we'll discuss this guy. It has an xref, and then an end of document. Now, what this document is this right here. It's our hello world document. So when you render this PDF, that's what you end up with. We'll come back to this again in a few minutes. But are we kind of comfortable with kind of picking out objects and what they are and understanding that better now than we were before? Okay. Like I say, there's no way I can teach you the whole language in 50 minutes, but I should at least be able to get you so you're familiar with it. Okay, let's talk a little bit about the document structure. Document has 4 different parts to a document. It has the header, the body, the xref, which we saw in the trailer. We haven't talked about an xref in a trailer. We'll do that later. The header, though, we did talk a little bit about, but let's cover it again. The header is a comment, and it has the word PDF and then a version number. So that PDF 1.1, that was a version that the minimal version that the Adobe reader has to be to read that document. So if I put in a percent and then PDF-1.7, if you're using a 1.6 reader, you cannot read this PDF document. You need at least a version 1.7 reader to read this document. So the smaller the version you can do, the better off you are. Now, why would you want to use a higher version versus a lower version? There are certain things that, as PDF manages their documents and says this is, we add this feature to it, but it's only available in this version, then you need, if you use that feature, you need to make sure that your PDF document requires that version. So it's better to have your numbers as low as possible for the features that you want to put in your PDFs. Okay, the next line that we saw is kind of gibberish. It was comment with some strange characters. Those characters I shouldn't say it doesn't matter what they are, but it really doesn't matter what they are as long as they're high byte numbers. So if you guys know that some differences between like the old Motorola chips and the Intel chips, and they stored numbers backwards internally. I don't know if you guys do this or not. But like even integers, some computers did high byte, low byte, and some did low byte, high byte. And Mac did it one way and Windows did it the other way, and you'd have to switch between the two. Well, for compatibility reasons, they want to know which is which, and this is what this is. This is basically, we have 3 characters here. This is really 6 bytes of data compressed into 3 Unicode characters, and they're high byte data, so it knows which order, whether we're high byte, low byte, or low byte, high byte. This is not required. I suggest it's in every document, but it's only required if you're doing things like pictures or things like that where it needs to know the byte order. So that's what that is for. Okay, the body. The body has 4 different objects. It starts off with a catalog that kind of defines the overall what's in the document. Then it has a pages dictionary telling you all the pages and where they're located. Then it has the page information itself. And then it has indirect streams for the pages. I'm not going to go a lot into that. That's a lot of detail to go into. I've explained it all through the notes. But just know that they're there, and we'll talk about those structures later, because I really don't have a lot of time to go through that in great detail. The xref, let's touch on that one. Xref starts with the keyword xref. Then it has a number that has the starting object in the xref and the number of entries in the xref. And basically, let me just go over here. It might be easier than just talking about it. So if we go over to here, it has the keyword xref. This is the first entry, which is entry 0. It's this special entry here. And then it has 5 different entries, 1, 2, 3, 4, 5. These contain the byte offsets to each of the objects. So if you start at the top of the document and you count down 18 bytes, that's where object number 1 starts. If you count down 77 bytes, that's where object number 2 is. If you count down 178 bytes, that's where object number 3 is. So you have to keep track of this little cross-reference. A PDF reader can read this and know exactly the byte offset of the start of every object. So that is a lot to keep track of in your head. That's why I said you can hand code this if you want, or you can use the 40 tools I'm giving you that does all this. Then it ends in a trailer, which tells it what the base object is, how many objects you have in the document, and then this one is important here, the start of the xref, because what will happen is when your PDF reader opens up your document, it'll start at the end, count backwards till it finds your start of the xref, and then count the number of bytes offset so it can tell where all the objects are. So the start of the xref here is the number of bytes from the top down to the start of the xref, and then it ends with a double comment EOF. Okay? Now, the reason I go over this is not to make you proficient at hand typing PDFs, but so that you can look at a PDF and not be so afraid of it and kind of pick out what's going on and tell what things are. Okay, so let's get to the more exciting stuff here. Where's my mouse? So we talked about that. Talked about the trailer. Talked about the root and the start of the document. Oh, the sample PDF. I went through that already. We saw the end of the document. So let's talk about the API. I've included in here a 40 API that has some commands. I went through in great detail in the documentation to tell you what each command does. But you first must call a PDF doc init. That initializes all the variables that you're going to be using to create the PDF. Then you add images to the document. And remember I told you that you don't need to necessarily add an image to each page. You can use an image once. So you add it to the document, and then you know what the reference is, and you can reference them on pages. You call PDF doc add page to add a page to your document. That must be at least once. You call PDF document save, and that writes out everything for you. Okay? So let's skip this and go to the demo and see how it all works. And actually, I'm just going to go to mirror displays here. Is it running someplace here? There it is. So demo 1. Let's just run it. I'll explain what it does while it runs it. Okay, so it calls PDF doc init first, no parameters. Like I say, that just initializes all the variables it's going to be using. All this is written in 4D code, so you can go see what it's doing. I'm going to call an add page, which then just puts that into memory. L is for a landscape page. P is for a portrait page. You can put them in. I define my own page widths inside the 4D code, and that sets the media box. Remember I told you the media box was the size of the page? All it does is set the media box here. I say I want to add some text. I give it X, Y coordinates and a font size. The X, Y coordinates, if you remember, I inverted the axis for you. So the upper left and Y is going to go down. So consider 0, 0 at the top of your document. The axis will be inverted. So this will add hello world, 50 across and 120 down. Then I save the PDF document, and then I open it. Open just calls an open URL, and there's the generated document. I have another little more complicated one that actually adds an image. Oh, by the way, if we wanted to look at this document here that we just created, it looks very similar to the hello world we've been using in our class. It's a version 1.3. There's your high byte numbers, your catalogs, your objects. Here's where it said hello world. It's the inverted X and Y coordinates. Let's do one that's just a little bit more complicated. Demo 2. I call the PDF doc init again. This time I add an image. I pull it in from a reference folder, and then the API is documented in the comments to do this. So that adds an image to the document. This creates a page. This time it'll be portrait instead of landscape. Now I add the image to the page. Then I set some text in there, add a line in there, do a save, and then I open up the document. And there's the document we just generated. Okay, about out of time, so do we have any questions? Yes, go ahead.
One of the things I was looking at is like appending PDF documents one right after the other. So there's some PDF drivers out there that we've been using to append one right on top, one right after the other, create a pretty large PDF in a single file. So I'm assuming this will be able to do the same thing here.
This right now does what you see. To append a document, you can concatenate cross-references because you can actually, the cross-reference has to be set up for both. You have to adjust the end document and the start reference. So you have to renumber all the objects in a document to combine them. A document's a little bit more than just saying, hey, stick this onto the end, because you have to rework the whole document structure. So I'm going to take that on in the future. I have not written 4D code to do that yet. If you would like to do that yourself and contribute it, we have the PDF reference. I've included that as well. That gives you everything you want to know about PDFs in 1,300 pages. Yes, question? Yes, the PDF reference is on the stick that I'm sending. Right, all I put in these is I hard-coded Arial fonts, and you can go tear apart the 4D code and look at that. My purpose isn't to give you like the all-powerful 4D tool, but to give you enough so you can understand the PDF documents, how they're constructed, so you can kind of understand the code and play with it yourself. And if this works for you enough, that works. If it doesn't work for you enough and you want to give me like money for my programming pizza fund, I might customize it more for you.
My second question would be for the guys that are doing PD or 4D Write Pro, are they going to be doing stuff with creating a, as a PDF, or is that?
I would love it if they would. I would even give them my code and tell them all I know about the PDF reference. I don't see why they couldn't. I don't know if it's a priority for them. I assume it will be. One thing that will come out, I know that version 10 of Windows now has a PDF driver built into it. So you can, on a Mac, just say set your destination to PDF. On Windows, you'll be able to set your destination to PDF in version 10. The advantage of coding them yourself is you'll have a lot more control. You'll build a lot tighter documentation. Or like, you know, if I run one of these through a driver, it comes out, it's about 100K. I run one of these through, and it's about 1K. So it's a lot tighter PDF. Yes? Fields. I started looking into fields. This does nothing with fields at this point. Maybe I ought to do like an advanced class next session or something on PDF, advanced topics. We can handle fields, concatenation, stuff like that. But they're all in the specification, if you want to dig through it. Yes?
Let's do it, say I'm doing a list, and it's multiple pages long. Are you handling the end of the page in this code?
I do not. I treat this just like a thing, but you can handle the end of a page just like you would with a print form. So if you keep track of a line counter, and you put in a line, you increment it, increment it. From the page size, if you look inside the page, I set 2 process variables, one with the page width, one with the page height. And when you put in a footer, I put in like a special footer or something, you can specify the size. You know how much space you're using, jump to the next one, add your header, footer, add a new page. You can keep track of it yourself just as you would with a print form. So you have the capability, but it's not built in to do an automatic rollover. Any other questions? Yes? Yes, let's look at the one that I created in the demo one. So if you go down here, you have an xref. The xref starts with the first row is going to be 0, so this is object 0. Object 0, and it ends with an F or an N. F means it's free. And the special number 65,535, if you convert that to hex in your head, is FFFF, or if you convert it to decimal and you're limiting, you get a -1. So that's where that number comes from. So that says that this is the end of the cross-reference. Otherwise, if this was not the end, it could link to another cross-reference. This is the byte offset from the top of the document to the first object. This is the byte offset to the second object, the third object, and the fourth object. We have 4 objects in this thing. There's 3, number 4. The trailer has the start of the xref. The start of the xref right here is 726 bytes from the top. Does that answer your question? It just makes it so that a PDF reader can know where each object is. So for indirect objects, like I said, they don't have to be in order. So if it says, ooh, object 8 is my reference here, it can go look up and see where object 8 is, know the byte offset, and pull in object 8, and then stick it up there as it needs. It's just a complete path to every object in the document. Yes? I'm sure that's what it is for. Completely rendering efficiency and document sizes, because if you use reference objects, even a string, if you have a string multiple times, like in a footer, if you make a reference object, you can reference it in 4 bytes where the string might be 80. And so you can make a much tighter PDF that way. All right, well, thank you.